Okay, so hi everyone. This is the first devlog from my side on my implementation of the what I call the NervLuna system, which is an automatic binding system for C++ into Lua using the Clang library. We are jumping here right in the middle of everything, but yeah, we actually have to start somewhere, I guess. And I've been working on that since some time now, so I will be continuing in this recording. What I'm doing right now is here you see I have an AST tree structure dumped into a file. In fact, this is executed on the Qt library. And I mean, just part of the Qt library, I guess. I'm providing only a single file for the moment, and the idea I have is to try to figure out what I need to really parse in there and optimize this parsing to, well, first understand what all the nodes are doing and try to reduce the number of lines that we get here in this final dump result. So I've already implemented something for the function template. So you see when I get to a function template, I'm going to, yeah, since this is a short returning array, I'm going to retrieve the result type, the function name, all the template parameters will be added here, and then all the arguments will be provided in parentheses. So this is basically the part that is computed and requires some work parsing the children of this node. And when I'm done with that, I do not display those children anymore. So I don't have to visit all of them and display one line for each of them. I've done that for function template, also for function declaration. Here we see that we retrieve the return result, the function name, and optional parameters. So we have parameters here, and then we do not display the children. So the next step I want to take is to do the same thing for the CXXMethod. So I'm currently studying a bit what we have here. So when we have a CXXMethod, that must be in some kind of class template or a class declaration. So that's fine. Maybe another one that's going to be templates. Yeah, maybe it's easier to find a class declaration. See from the hand. Okay, so we have a class declaration here and a CXXMethod in there. So as far as I understand, I mean, it's a bit like for the function themselves. In fact, I don't know where we can find any kind of reference on that. I could not find. I'm using the Clang C library tutorial, and yes, I mean, maybe I should go into the documentation, official documentation, and try to find. Oh yeah, that was actually written by me, so no, I mean, you don't have a lot of information on how to do this parsing, I believe. I mean, I could not find anything really relevant so far. So if anyone has an idea on that, please let me know in the comment or something. Anyway, we'll check that another time, I guess. So what I understood by myself so far is that when you have a method like that, the first type ref that you see is going to be the return type of the function. So in this case, yes, it's pointing to this Q signal blocker, and the function prototype, or the function name that I'm extracting for now, is really returning this class. So it could make sense. Then you have a first parameter declaration, which is referencing the type of that parameter. So you have a type ref here, and it's again the same thing, but this one is pointing to this location, so the first parameter here. And that's it for this method. Except that I've seen a few locations where I cannot really make sense of that. Well, here it's okay. We don't have any parameter and we don't have any return value, so it's void. Okay, that's fine. But let's try to find something else. No, type. Oh, well, no, here you have it, for instance. This one is strange because you have a first type ref referencing a type. So you would assume that this is for the return value. Okay, so we have the return value here. And then you have another type ref, which is not inside a parameter. So yeah, that doesn't match my current understanding. I don't know what this means. So yeah, I need to be careful about that part. Anyway, let's get into some coding now. So this our CXXMethod. I have this cursor class and function here to get the full name of a cursor. So we are already handling this specifically for function declaration and function template here. So we'll add another one, which will be the CXX method, and we will get CXX method full name. Next, we need to provide this implementation, which I'm doing just above. So we'll start with a duplicate of this function. To get the CXX method full name. Okay. So we provide the cursor pointing to this, well, method. Then we have the row name, which is the full row name already extracted by default, just taking the cursor spelling and all the parent's name. We will finally output decorated name with the return types, the parameters, and optionally the attributes. Let's do some cleaning actually, by the way, because this function declaration was taken from, well, let's just rename that also actually. It's shadowing the previous one. Okay, saving it. And in there, I was actually taking this as a copy of the first one, which was the function template. And in the function template, you would also need those template parameters, but it's not the case here anymore. So we can get rid of this entry. And those two lines also, you do not need them. Yeah, there's also something strange going here with additional type ref, a bit like what we have seen here for the duplicate type ref here, because I was just trying to check the first one, and then when return time is specified, then the other type ref, I don't know what to do with them. Anyway, okay, and here we are not using the template name, so this line can go away. Same thing for the CXX method. Get a bit of that. This I'm not quite sure yet what I will ignore or not ignore. So I'm commenting this part for the moment. And the name that I should use is rather CXXMethod. Okay. When we have a parameter declaration, the idea is a bit the same in every cases. We can just try to get the full name of the type of that parameter, which seems to be working so far, and then the name of that parameter, if any, and just put the type and then the name. If it's an attribute, we have that attribute list. Finally, if we did not find any kind of return value, we just get the return type here. And in fact, I'm thinking maybe I could make this even more generic and just get the return type anyway, and do not try to perform this this check here. What I could do is to confirm the return type, because first here I'm getting this return value, and then if it's not null, I mean, let's get a copy of that. And if it's not null, then, well, we'll have to get the return. Let's call that R type, sorry. So you'll get, let's take the name for the moment. Could also check directly on the type object if the types are equal, but with the name at least we can display something. So if it's not nil and it's not the same, we can just throw an error in that case. Okay, and in any case, we will be using this R type instead of the return type here, which is making checking this red type completely optional, but at least it could confirm that the understanding I have is correct or not. Again, we don't need the template thing. Okay. So with this first version, we should be able to parcel the CXX function. I'm not using that elsewhere. Oh, wait a second. What was I doing then? What was I doing for this one? Just a default processing, which was what? Oh, there was a valid type, I guess. Because it's not checked here. It was not here yet. Was not an attribute. But the type was valid, so it was returning this, I guess. Anyway, Let's just generate the bindings again. Okay, so we do have an error here because we have some compound statement in some of those CXXMethod nodes, so we need to ignore them because we don't know what to do with compound stuff. So just ignoring them here, not even displaying this, and trying again. Ooh, okay, that's interesting. So what does it mean? It means that we cannot really use this what I was using before, this red type, because red type is just going to give you the row type itself. That's the first one, but it doesn't tell you if it's a pointer or const type or something like that, which isn't good. So the type ref is pretty... The first type ref that we're going to read here is just referencing the base type that we have for the return. What we could check maybe then is what happened if we try to retrieve the row type from the return. I think we can do that. So let's do local row that type equals. So we take the return type, and you can get you can call get. No, that's a name. So we don't want okay, just be careful what you're changing here. I will be using the name here. So let's call that R type name, and that will be R type get full name. Like this, and then we use this name, which is a fully decorated return name, so as part of the prefix here, but we can still do the check with the R type. So let's try. So this is really a CX type, C9 CX type. So let's try to get canonical. That's canonical type or something else. I don't think it's canonical type. Unqualified, I think. Yes, unqualified type should be it. So we get the unqualified type, and I think we can just compare the name actually. So let's call that U type, or just U type get full name. We get the full name of the unqualified return type, and we just compare that with what we have been reading from red type. So basically we're just trying to extract the LM part here. And that doesn't quite work. Okay. Really? It's actually funny. I'm not quite sure. How could LM be a type name in this context? Good question. Okay, so it doesn't seem to be working as expected. So, not quite sure what I can do with that. Do we have another function similar to this one maybe? What could that be? So with type get return type, element type get pointer type. Yeah, maybe we could try that. Let's just go step by step. If we do something like if our type is pointer, then our type equal our type get pointy type. And I think we can do that before if it's counts, we should check that before. Is const qualified type. I don't know what we need to do. I somehow need to remove the counts qualifier. So it's funny that should be get the unqualified type. Or not? Let's see what this function is doing. So this is from the C++ part. And we should be able to find here. Get qualified type is const qualified. Okay. And this get unqualified then. Like CX type with the unqualified type from the current translation unit. Okay. So unqualified should really work and give us non-cons name. What is this function doing? Get unqualified type from itself, right? Doesn't make sense. Guess I need to think a little bit about that. Okay, so I've been thinking about this a little bit, and the way I see this now, it's probably not that critical because from what I see here, this is probably happening in a class template. So it's happening when you have a function where the return type is well, depends on the parameters that you provide for the template. In this case, it could be that the type system cannot really make the relation between what we call counts element pointer here and the base type. Well, that would be weird. But yeah, I mean, we'll get back to this at some point. For now, all I really need to care about is that I use this return type and I get the full name of that return type. And comparing the return value here, yeah, should work in most cases, but maybe not in all cases, so we should probably not care at all for now. Let's just remove those test elements. Then we also only keep the return type here. Okay, so we can probably just remove that. No need to compare. Here you probably don't need that. Return type will be void if it's void, I believe. Actually, let's just find where we have been using that before, because I'm basically rebuilding something that was already partially implemented. So I'm already parsing some function somewhere. So in the Clang parser here, that's where I am parsing a function, and I'm just retrieving the return types this way. That's all. If we cannot resolve, then nothing. Oh, if it's different from nil, it's okay. Otherwise, we need to resolve it. Okay. And we set that as return type. Okay, so this should be good enough, probably, to indicate the name, the full name of the function. So we have the return type name applied here. Sorry. So this also means that this red type value here is not really useful. And in fact, that means that those two sections here are not really useful either. So we can just maybe ignore this, saving some processing. So, or this, or this one. In those two cases, we don't do anything. And so we can get rid of this bot. Okay. Pushing this a little bit further, we can also apply that to the other functions. Let's do that. Before I move to the next one, I also need to remove this now. Okay, and now here, let's get the return type name, just as we did before. We're using this. So again, we normally don't need to retrieve the return type here. So ignoring those two kinds. And removing the return type. Okay, and finally we do the same thing for the other function, which makes me realize that we're doing the same thing for the free functions, since I normally don't, I try to avoid duplication of code as much as possible, so this is probably something that should go in a dedicated function also. Let's do that just after, but first, yeah, we keep removing type ref and template ref. Then we can get rid of those two, right? And we do not need the return type here anymore. Okay, so as I said, what is specific to each type here is what you're going to do with the children elements, so the nodes, children nodes. But once you have populated those arrays here, this part is common to all the functions, so we can add a dedicated function for that, and that would be build decorated name, I think. Let's build this. I guess it should be a local function because we don't want this to be visible. Build decorated name. It's going to use a cursor because I don't know why I don't know what I'm saying that. Am I using the cursor here? To get the return type, yes. Okay, so decorated function name. So what do we have? We have the attributes, which is a string list. We have the params. And we may also have the template names. Could be list of template, a string list on nil. And once we have all that, we also need the row name, so I probably want to put that as the first argument. So taking the and the cursor, of course. So we have cursor, row name, attributes, params, TPL names. Attributes with 2T, okay. And then we will basically do this part. Oh, and also we're returning the string. So basically that's the same thing as this. Decorated name of the function. So we take all this code and we return get function at name. No, build decorated function name. taking the cursor, we just pass the row name. We have the list of attributes, then the parameters, and then in this case we also have the template names. And we have to do the processing here, retrieving the return type for this cursor, which is normally a function. So we could probably just add check here also. Check return type is valid. Then we get the full name, and okay, the processing should be different depending on whether we have this element or not. So if the BL names is not nil, I mean, I think we can just do that. And otherwise, I mean, I guess we can just build that in 2 steps. First, we'll start with the suffix only containing the parameters, not this part with the templates. And if we have some template names, then we just prepend the templates list to the existing suffix. And in the end, we return this as a full name of the function. Right? I think this is okay. No complaint or anything. We need then to duplicate this part. So attributes, params, and here we return that, except that we don't have any template names in this case, so we can just not provide that. And for CXXMethod, it's the same thing. So this part becomes the function call. Good. Now let's try to run our generation again. Okay, an error. Why? We have an integer literal. How could you have an integer literal as the root child element for a function? Maybe in case we have abstract function and it's equals 0. That could explain the logic. Can I somehow show this? Let's just say we ignore this for the moment. So in the CXX function kind here, we're also going to ignore integer literal. Still not so good. Namespace ref. Yes, this one is pretty standard. I'm not quite sure what this means, but never mind. And export expression. Okay, same things as usual. Oh, by template type parameter in a CXX function. Okay, could make sense, I guess. Well, I'm not quite sure if it's making sense or not. Maybe we need to do something like that. Can a CXX function be template function? Okay, let me just keep track of that. I need to note this down. What should I do? I need to first check this integer literal in CXXMethod, and also check now this template type parameter in CXXMethod. Okay, so anyway, for the moment, let's just take this and we will ignore that part. Yes, of course, the other one was going to be a problem also. Declare ref. Okay, let me just handle all those errors and take you back then. Okay, so in the end, I had to introduce this one, and that was it. Now it's running and completing without error. So we need to find an integer literal in a CXX function. I don't know if this is something that can be done easily now. Well, too many of them. How can I find that? Yeah, I guess let's get back to the cursor and let's handle that a bit differently. Those three cases. In this case, we ignore everything, but else if we have one of those three cases, then we rather return special name like child get kind of spelling. With I don't know if I'm still using that somewhere. Yes, it seems I'm using that for the generic case. So let's not use this symbol. Let's put something else like before it, then maybe. Okay, so if we simply search for this symbol, we should find the location where we have this indication. So is lock free? Is lock free in the method here, which is in what? I mean, this is at root. Because all we have is this unexposed. How can you add that at the root? A CXX method? which is not in a class. No, that can't be. I mean, okay, that's because it's not, it's defined outside of the class, but it's still part of this class, I believe. It's just that template ref will give us the semantic parent. Oh, this is crazy, because here you have this prototype returning a bool. No, wait, when you have a bool, there's no type ref, because those are not really, well, complex type or anything. So yes, there is no type ref for the return in this case. So template ref is really a reference to the semantic parent then, I think. But what does it mean to have this integer literal compound statement? Would be good if I could just display some of this code, I guess. Yeah, we can retrieve the token for that. It would be pretty ugly to display that here, but how can I do this? Maybe I can just yeah, display a warning. Yeah, not returning here, of course. So no error. Let's just find where we have this in the log. A bit of a mess. Anyway, it's a template inline bool q atomic thread templated on 4, and that's a function in this with no parameters and simply returning true. Okay, so it's a CXX function, and the integer literal is for this parent part. Yeah. So it goes with the the template ref. It's a pity that this is not made a child of the template ref or something. I mean, this is a bit confusing when built this way. But anyway, we probably just need to accept that now. And we don't really need to parse it, because we'll get that from the semantic parent. Right? Oh no, we will not get that from the semantic parent, because semantic parent will not have the integer literal. Let me see if we were to use a parent name. yeah, let's just use the full name here that we have computed. Oh yeah, the row name, that's what we have computed. So finding the semantic parent as being this, but I'm not quite sure that this integer literal is taken into account. Okay. So for now, yeah, I'm not sure what to do with that. So I just say we just ignore this one as a regular one. So we're left with those three options. Okay, let's find where we have only 16, so not many of them. So CXXMethod next in QString tokenizer base, which is a template class again. Oh my. And we have those template parameters. Function template Q tokenize. Whoa. And what do we have in there? We have, yeah, just those template type parameters and a template ref. That's giving us the what? Auto returning this, but inside of this we have the next result. So type ref, next result, link to sys template ref. Let's check the tokens. What am I supposed to look for again? Yeah, the string. Hello. So template type name. A stack type name little. So it's a template function. Auto this class taking those two template parameters. Function name is next. We'll take a tokenizer state. And then a state, which is interesting because what is the type of those? Do we have, so in next parameter declaration we have state, but we don't have that tokenizer state. Oh no, I mean tokenizer state is a type, right? Okay. So yeah, tokenizer state and that's the name of the parameter. So we have a single parameter, which is okay, that's what we are expecting here, which is state. And we have the type ref, so we get the type of that parameter, but normally we don't even need to go that far. We can read the type directly from param declaration here. What is a bit more confusing is this part. So it's a function in this class template. So in the end, it makes sense. Let's just see what kind of display we get. I mean, the idea is really we need to parse the class template first, maybe. So yeah, not that critical for now. For those two template types, template kinds actually. Now we're left with the last one, which is the bool literal expression. Another funny one. Oh, yeah, not here. It's here that we can find one. Inline bool blah 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 t. Yes, that's where I was expecting to see it. It's a bit like the integer literal. It's because that's part of the template parameters that are provided in the parent class, right? I guess, yeah, we probably don't need to care that much for those functions. I don't want to be binding that at the end. So here we should also find this entry, and only one of it. So we have a type and then true. Okay. So yes, I think we can also just safely ignore this possibility for the moment. Which means that this part is not needed anymore. And we can simply pause everything. Okay. And so we have all of those CXX method now returning complete full name, decorated full name. Let's find another one. Just this one is not yet absolutely perfect because we are still not parsing class templates properly. So will come eventually, but then yeah, the parameters and all are okay. Good, which means that at this point, when we are traversing the graph, the IST graph, we don't really need to go into the CXX method children's anymore. So that's fine. We get IST, AST, and here we also don't want to pass the CXX method, which means that now all of those elements under CXX methods will be ignored, so not displayed here. For the moment, we have that number of lines, so it should be reduced again quite a lot. If we do another run now, so let's try that. Okay, so significantly less lines. And for the CXX method, we just have those names. We could do something similar for CXX destructors and CSX constructors. I mean, these are basically methods anyway. I mean, it will behave the same way, I think, here. How can I kind of process this? So we have to get back to the get full name. And what should we do? If we have a CSX constructor, maybe we can just use that again. So p kind equals ck. I mean, oh, it's just constructor. Let's see what we get with that. No, not so good. Yes, because when we have a constructor, you may be initializing some members in the class. So it makes sense that you have those member ref, which should then be ignored. CXXMethod on the full name. I guess we can just put that here. Call XPR. Okay, init list. This is also something that seems logical. We may have init list expressions in the constructors, I guess. Functional cast expression. Well, starting to get a bit funny. I don't know what this is exactly. Binary operator. Yippee, let's go. So again, I get back to the video when I'm done listing all of those type of nodes. So here we are. Now it's completing properly. Let's maybe find some of those constructor. Initializer list. Okay. No, what did I do? Come on. Get the first argument and so on. Here we have a type parameter. Okay, it seems to be working as expected, so we can probably ignore those childrens also now. This, what is that? Wait a second. No, yeah, that's the type of the parameter. Okay. Reference type, and in there we have only one parameter. Is that correct? Here we have that parameter. Okay. So it seems to be fine. So back to the get AST, and at the end of the function we can also now ignore the kind CK constructor. Let's put that in multiple lines. And let's just do the same thing for the destructor. Get full name of pkind equals ck destructor. Okay, no error. That's good. Let's find a destructor. CXX destructor. Oops. And we have the full name of the function retrieve here. Usually there's no parameter, so it's simplifying a bit this node. Okay, so same thing, we can also ignore that in get AST. Good. And so generating the AST again should produce a smaller file and take a bit less time. Every time it's taking a little bit less time. We started at about 10 seconds, so it's already reduced significantly. How many lines do we have now? Yeah, not so much less. That's true. Okay, good. So I'm going to stop this recording here for this time, and we'll take another session a bit later, and we'll continue on this.